All right, good morning, everybody. We are getting close to the end. Get ready to focus to be successful. Welcome to the Test 21 review. One coming at us from lessons 79 and 90. It starts off saying, the denominator of 11/12 is 12. Write a fraction equal to 2/3 that also has a denominator of 12 and subtract that fraction from 11/12. So the main gist of this problem is right here. Write a fraction equal to 2/3 that also has a denominator of 12, right? So we've had problems like this quite a bit. Remember, the secret to success is finding the fraction that's equal to 1 that you're going to multiply by, right? So you're going to set it up like this. 2/3 times what is going to give you an equivalent fraction with a denominator of 12. Look along the denominator row. 3 times what is going to give you 12? The answer there, I hope you know, should be 4, right? And if I'm going to multiply the denominator by 4, I'm also going to multiply my numerator by 4. So now I go numerator times numerator, 2 times 4. Well, 2 times 4, that's going to give us 8. So I have 8/12, but I'm not done yet. Now they want you to subtract that fraction from 11/12. And this gets a little bit tricky in reading. From 11/12, sometimes students want to go and put 8/12 on top and subtract 11/12. But you're subtracting it from 11/12. Just think about it logically. Which number are you going to put on top to subtract? The smaller number or the bigger number? So you're going to end up writing something that looks like this. So I have 11/12 minus 8/12. That's going to give us 3/12, right? But I am still not done. 3/12. I can reduce what would be the greatest common factor, the biggest number I can divide into both 3 and 12. That number, of course, would be 3. So the final step, 3 divided by 3 is 1. 12 divided by 3 is 4. So just a new spin in the wording on a concept we've actually practiced quite a bit, right? A shoebox has the shape of what geometric solid? And my advice here, remember, we're allowed to use our books. So if you're not sure, turn to lesson 83 and look at the chart. A shoebox would be a rectangular prism. All right, let's check out this one coming at us from lesson 96. And I still have some people getting confused with these. You have 2 rules with dividing fractions. First, you want to change your divide sign into times, right? Next, you'd want to write the reciprocal of the second fraction. Instead of 1/2, let's get those numbers flipped around, and you would end up with 2/1, right? Then it's simple. Numerator times numerator. 7 times 2, that's going to give us 14. And denominator times denominator, 5 times 1, that is 5. But I'm not done yet because I have an improper fraction there. My numerator is greater than my denominator. So 5 is going to divide into 14 2 whole times, right? It would multiply back for 10, which would mean there'd be 4 left off of that 14, and my denominator stays the same. 14/5 is equal to 2 4/5. Check out this one. Arrange these numbers in order from least to greatest. And the secret of being successful here is think. What's more than a half? What's less than a half? What's 1 whole or greater? So 0.1, really, if we thought about him as a fraction with his real name is 1/10, right? So half of 10 would be 5. Compare that to the numerator. Is he more than a half, less than a half, or equal to a whole or more? He'd be less than a half, right? Well, 2's pretty easy. He's going to be greater than 1 whole. And now 2/3. Take a look at the denominator. Half of 3 would be 1.5 or 1.5. So is this guy more than a half or less than a half? So then it's going to be pretty easy to put these guys in order from least to greatest, right? I'm going to start off with 1/10 because he was less than a half. Then I'm going to go over here to my 2/3 because he's more than a half. And then I'm going to go to my whole number 2 because he's equal to 1 whole or greater. Check out this one coming at us from lesson 46. 2/3 of the 18 cars were new. How many of the cars were new? Well, 2/3 of 18. So remember the old rectangle trick. We've been doing that for a while now. And divide by the denominator. What would be 18 divided by 3? That means each third would be equal to 6, right? All 3 of these thirds, if I added them up, would equal 18. So 2/3 would be equal to 12, right? Because you have 6 for a third and 6 for another third. Check out this guy coming at us from lesson 61. It starts off saying segment AD is 6 4/10 centimeters from A all the way over to the end of point D is 6 4/10. And then it tells us that segment AB is 3 9/10 of a centimeter. Next up, it's telling us that segment BC is 1 4/10 of a centimeter, right? And they want us to go and find the length of segment CD. So we got a couple different things we have to do right now. We have to figure out what would be the length of segment AC to start off with. To figure out the length of segment AC, I'd have to go and add segment AB, which was 3 9/10, plus I'd have to go and add segment BC, which was 1 4/10. So let's start off by getting these two numbers added up. 3 9/10 plus 1 4 more tenths, that gives you a total of 5 3/10 for segment AC. But I'm not done yet. Now I got to take the whole length of segment AD, which one more time was 6 4/10. And let's go and subtract it from the length of segment AC, which we found out was 5 3/10. 6 4/10 for the whole segment of AD. Subtract down your combined lengths of AB and BC and subtract the two for a grand total of 1 1/10 of a centimeter. Check out this one from Investigation 10. Which of these angles could measure 120 degrees? Or which of these could measure 45 degrees? And the big secret here without breaking out a protractor is remembering obtuse is more than 90 degrees. Acute is less than 90 degrees. So if I'm looking for something that would be 120 degrees, I got to think which one of these would be obtuse. The answer would be right here because this is definitely more than 90 degrees, right? Which one of these could possibly measure 45 degrees? Well, which one of these is acute? And your answer is right here. This guy is definitely less than 90 degrees. He's a cute little angle. So don't worry about not having a protractor. Just remember the difference between obtuse and acute. Check out this one. Here we have 4 and 8 twelfths plus 3 and 6 more twelfths. So remember, the secret here, you want to deal with the fraction side first. 8 twelfths plus 6 twelfths is 14 twelfths. Now we got to go and simplify and reduce, just like we're doing on that quiz, right? Well, 14 twelfths, I think I could divide both sides by 2 to get it reduced. If I reduced 14 twelfths by dividing both sides by 2, I would end up with 7/6. But I'm still not out of the woods yet because 7/6 is an improper fraction. So let's go ahead and change it into a mixed number. 6 divides into 7 one whole time. There'd be 1 left over and the denominator stays the same, right? 7/6 is the same as 1 and 1/6. But I'm still not done yet because I haven't taken care of my whole number side yet, right? Don't forget about that. 4 plus 3, hey, that's 7. That's easy enough. But here's the part kids sometimes forget. You got to remember to bring the whole number answer over. So now 1 and 1/6 is the answer of the fraction side. 7 is the answer of the whole number side. Put the two together and what do you got? 8 and 1/6. Check out this one. We still have some people occasionally struggling on 3/5 times 10. Remember, you can write any whole number as a fraction if you give it a denominator of 1. Every so often I still have people struggling there. Then it's just numerator times numerator. 3 times 10, hey, that's going to give us 30. Denominator times denominator. 5 times 1, that's going to give us 5. But I have an improper fraction. I don't want to leave it as 30/5. How many times does 5 divide into 30? The answer there is 6 whole times. Check out this one coming at us from lesson 99. We have 4 and 39 hundredths plus 1 and 8 tenths plus 3. Remember, if one of the numbers has a decimal point on it, they all must have a decimal point on it. Then I'm going to go and line up the numbers at the decimal point. So I got my numbers lined up nice, neat, and straight at my decimal point. Well, next step, I want to fill in any empty places with zeros. So instead of 1 and 8 tenths, think of that as 1 and 80 hundredths. Instead of 3, we'll put in 2 more zeros and have 3 and 0 hundredths. 9 plus 0 plus 0, hey, that's going to give us 9. 3 plus 8, that's 11. I'm going to write down my 1. I'm going to carry my other 1. 1 plus 4 is 5, plus 1 more is 6, plus 3 more makes 9. But my answer's not 919. Just bring the decimal point straight down, and that gives us 9 and 19 hundredths. Check out this one. Draw a rectangle that's not a square and show its line of symmetry. So I'm going to start off with the rectangle as long as you don't have all 4 sides the same. So now you want to think, how can you fold the sides together so that they meet? I could actually fold it across horizontally, right? I could actually fold these 2 sides together and they would meet up. I could also fold it vertically this way, right? If I folded it across, these 2 sides would meet up. There is no way this has diagonal symmetry. If I started folding on that corner, I could not get it to meet that corner there because it's a rectangle. So this rectangle only has 2 lines of symmetry. Check out this one coming at us from lesson 103. Find the volume of this rectangular solid in inches. Remember, we want to go length times width times height. Well, looks to me like the length is 3, the width is 4. 4 times 3 is 12, plus 2 more for the height. That's going to give us a grand total of 24. But we also want to make sure we label it correctly. They're asking us to find the volume in inches. So I multiplied 3 numbers. So I want to make sure to use that 3 and label it as cubic inches for a volume problem. Check out this one. I still have lots of people on a test forgetting to do the second half of the problem. Do the work in parentheses first, but don't forget about the first half. So I have 2 and 5/6 minus 1/6. I think that's easy enough to do in our heads. We should be able to know that it's 2 and 4/6, right? But then I'm going to take my 7 and I'm going to subtract 2 and 4/6. Now we can start. The fraction side first. Nothing. Take away 4/6. I can't do it. I have to borrow from the whole number and write 1 as a fraction with a denominator of 6. How many 6 equals 1 whole? The answer there is 6. Okay, so now I can start subtracting. 6/6 minus 4/6. That's going to give us 2/6. 6 minus 2, that's 4. But I'm still not done yet because 2/6 can be reduced, right? I can divide both sides by 2. 2 divided by 2, hey, that's going to give us 1. 6 divided by 2, that's worth 3, right? And then don't forget to bring your whole number over. So I ended up with, instead of 4 and 2/6, I have 4 and 1/3. Check out this one coming at us from lessons 101 and 104. Round 9 and 471 thousandths to the nearest whole number. When you're rounding to the nearest whole number, you have 2 choices. You can either round it to 9 or 10, right? And the secret there is looking at the next number. If it's more than half, round to the nearest whole number. If it's less than half, leave the whole number as it is. So 4 in the 10th spot, well, that's less than half, right? So that is closest to 9. Let's try it again over here. Round 2 and 2/3 to the nearest whole number. Well, my 2 choices for an answer would be either 2 or I'm going to round it up to 3, right? Is 2/3 more than a half or less than a half? If it's more than a half, we're rounding up, and it is more than a half. Hopefully you know. So that rounds closest to 3. And that, my friends, is the end. You want to go slow, go careful, double check every question and answer. Good luck.
That's all, folks.